This is chapter 4.4, evaluating the linear model. The coefficient of determination, which is r squared, gives us a measure of how much better the regression model is at predicting someone's weight, given their height, versus using just the mean weight as a prediction for everyone. So the coefficient of determination is simply the correlation coefficient squared. We read that as r squared. The r squared values are usually reported as a percentage between 0% and 100% and tell us how well the regression line summarizes the data. All right, so number 3, an r squared value of 0% indicates that predictions from the regression line are no better than using the average y value. In other words, the predicted weight from the regression line is no better than using the average weight of all people in the population. In this case, the correlation is r equal to 0, and the scatter plot may look something like the following. So you imagine having weight down here, or height, and weight. Again, knowing someone's height isn't going to help us predict their weight. So if the correlation is 0, notice that r squared is equal to 0 squared, or 0. And in percent form, this is 0%. Number 4 is another example. An r squared value of 100% indicates that predictions from the regression line are perfect. In other words, the predicted weight from the regression line is 100% better than using the average weight of all people in the population. In this case, the correlation is r equal to 1, and the scatter plot may look something like the following. So again, if we imagine height here on the explanatory variable axes and weight over here, that regression model or regression line is going to give us perfect predictions. Much better than if we use the average weight for all of our predictions. So all predictions are perfect, definitely better than using the average weight. If we take a closer look at this, if r is 1, then our coefficient of determination, r squared, is 1 squared. And 1 times 1 is just 1. And that in percent form is 100%. Okay, number 5, an r squared value between 0% and 100% indicates that predictions from the regression line are better than using the average y value. In other words, the predicted weight from the regression line is not perfect, but it is better than using the average weight of all people in the population. In this case, the correlation is between 0 and 1, or between 0 and -1, and the scatter plot may look something like the following. So we've gotten back to our height and weight example. Okay. In this case, the correlation between the height and weight is r equal to 0.717, and r squared is 51.4%. So I'll leave it up to you to verify. If you take 0.717 and multiply it times 0.717, you should get 0.514. And then again, in percent form, 51.4%. And so the question is, what other variables may account for some of this unexplained variability in height? So again, if this is the percentage of the variability that is explained, or we can say it's the explained variation or variability, then we see that roughly half of the variability is still unexplained. Right, so some other variables might include things like lifestyle, diet, genetics. Okay, there could be a bunch of other things as well. Okay, so number 6, so the higher the r squared value, the better the predictions. What does this r squared value mean? One interpretation is that it measures how much of the variation in the response variable is explained by the explanatory variable. How much of the variation in weight is explained by height. Okay, and that's our explained variability that we were looking at earlier. So for example, if you're given a person's height, then you can better predict the person's weight. Again, your predictions aren't going to be perfect, but they will be better than using the mean weight of the population. Okay, so number 7, the following scatter plot contains data on waist size, given in inches, and the weight in pounds for a sample of people. This scatter plot can also be found in your textbook. It's on page 175. The r squared value for predicting weight from waist size is 81.7%. R squared is 0.817 or 81.7%. Okay. So first question, which variable, the height or the waist size, is a better predictor of weight? Remember when height was your predictor variable, your explanatory variable, you had an R-squared value of 51.4%. Now using waist size, our R-squared value is 81.7%. So the better predictor of weight, that's going to be the one with the higher R-squared value. So that is waist size. The higher R-squared value indicates that we're accounting for more of the variability in weight by knowing the person's waist size. Okay. So waist size accounts for more of the variability in weight than height does. It means predictions of weight using waist size as the explanatory variable will be better on average than the predictions using height. Last question. What's the correlation between waist size and waist? Well, if R squared is 0.817, then correlation, which is just R, is the square root of R squared, or the square root of 0.817. So leave it up to you to verify that that is 0.904. So waist size and weight has a higher correlation than height and weight did. And so we're going to finish up with some facts about the R-squared value. In its name, it's called the coefficient of determination. It measures how well the data fit the linear model. All points lie in the regression line, then R-squared has a value equal to 1 or 100%. This means the predicted Y values from your regression line are equal to the actual values. Your predictions are perfect. If the points are tightly clustered around the regression line, then R-squared has a value near 1 or 100%. This means the predicted Y values from the regression line are likely to be close to the actual values. If the points are more spread out from the regression line, then R-squared has a value closer to 0. The predicted values or predicted Y values from the regression line are likely to be better than using the mean Y value, but may not be all that close to the actual values. And if there's no linear trend and the points form a shapeless blob, then R-squared has a value near 0. The predicted Y values from the regression line are no better than using the mean Y value. R-squared gives us the percentage of variation that can be explained by the regression line, and it only works with linear associations. So again, you should check a scatter plot before you calculate R-squared.